To wrap up our probability simulation lesson, I have a third and final example in which your charter airline run has 20 passenger spots. To make it a little bit more difficult to fill the seats, I have its history say that 7/9 of the reservations will show. And when we figure out the expected value, so for each flight, we have found out that if we take 7/9, the success rate, times the number of trials, which in this case represents the 20 seats, we find out that I should have 15.555 seats filled on average per flight. So that means over 4 seats will usually go unfilled, and I could have all of them filled, but then I could have a lot of seats on one day not filled at all. Let's take a look at a couple simulation runs that I've had. Because that my fractions denominator is 9, I did use 9 down here in my second one, but I also chose another multiple of 9, which in this case was 27 up here. So if it's 7/9, I was essentially thinking this is 21 27s, while down here I was thinking this is 7/9. So here's a little trick at this point. If you're going to go rand times 27 plus 2, I'm going to tell you right now, the last number should be 1 less than whatever 27 plus 2 is. So this number right here is 27 plus 2 minus 1, because that number is going to be counted right here at the beginning. So let's take a look here. If I go int random times 9 plus 10, I can tell you right now that this last number that I'm going to need is going to be 9 plus 10 minus 1. Again, the minus 1 is because the 10 itself is one of the numbers being counted. I'm not going to run simulations again on the calculator because, well, we've already done one here, we've done one here, and I've shown that in prior lessons. What I will, however, show is the Excel spreadsheet where I've done this on more than a few occasions. Again, 200 different times. And you will see that I had as many as 20 occurred one time out of 200, while I had as little as 11 show up, and that occurred as many as 8 times. So let's go ahead and fill in those frequencies on our table here. So let's go create a couple extra columns. I don't usually need to have that many different columns, but again, I also don't have a class size normally of 200 students. So we have 11, a 12, a 13, a 14. So 11 occurred 8 times, 12 occurred 10 times, 13 occurred 15 times, 14 occurred 22 times, 15 occurred 36 times, 16 occurred 34 times, 17 occurred 43 times, 18 occurred 25 times, 19 occurred 6 times, and 20 occurred 1 time. If I was going to work out the experimental probabilities, I would take 8 over 200, and what I'm going to just do here is just write down what it is as a percent, which in this case is 4% of the time. This ended up being 5% of the time. 13 occurred 7.5% of the time, 7.5% of the time. 14 occurred, it looks like 11% of the time. And 16 was 18% of the time. 16 was 17% of the time. This was 21.5% of the time. This was 12.5% of the time, and 3% of the time, and finally 0.5% of the time. And let's just take some comparisons to 15. 18% compared to what I expected was 19.3%, not bad. 17% actually occurred. I was expecting 21.2%, so it's a little lower. But then again, if you look here, 17, 21.5% is higher than the 17.4. It's almost like this should have gone with that one should have gone with that, but that literally is 1 seat apart. So I guess I'm not too surprised. 12.5% versus 10.1 or 10.2% expect. Okay. 3% is just a little bit lower than 3.7 or 3.8%. And 0.5%, well, it's supposed to be 0.6%. And when you can only have by 0.5s, I think that's pretty darn good. So really, when I'm doing 200 simulations to get all 20 seats filled with that low of a probability of them showing up is pretty difficult. And so down here, when I asked was the theoretical probability of getting at least 19 reservations to show. This is where I went probability of 19, and I added the probability of 20 to come up with 0.04406. Okay, so I took these two numbers right here and added them together. All right. I did do the theoretical probabilities of my two simulations. I did do, in this case, I figured out, I had, in my case, my 16. I did the math here, and that just matches up to that one. And the 14, I did not do because it wasn't part of the table. So I'll just say that's the work to show that 14 should have occurred at 13.8% of the time, and that's 11%. And if I kind of go back to my mean reservations, I've shown you how to do that in the past. For my 200 simulations, in my case, I did find this to be 15.55. And since I was expecting it to be 15.555, and I actually got 15.55, I mean, we really did a good job kind of matching up to our expected value there. So I'm very pleased with that. As we move on to the second page, let me acknowledge that I did go through the first part of our example a little faster than I had in prior examples. But that's because I want to focus now on the overbooking, underbooking aspect of our simulation. I'm using the first setup where I had int random times 27 plus 2, and I'm going to keep filling up my airline seats until I have 20 reservations. So this is very similar to what I did in my hotel booking situation, except, well, more seats and a little harder to do. So that's why you might see boxes like these where it took multiple reservations before I would actually fill it in. In this case, it took me 28 reservations to fill in all 20 passenger seats. I did this again, except this time it only took me 24 reservations to fill 20 passenger seats. Well, when I ran the simulation 200 times, let's just take a quick peek at the results. 4 times I was successful to be 20 out of 20, where I would not need any additional reservations. But there was at least one time where I needed 33 reservations to fill 20 seats. That meant I had 13 no-shows. So the question is, what should be the magic number of reservations that I take? If I take too many reservations for my airline, I'm going to have to tell people that they're going to have to wait for another flight. I may have to deal with the social media ramifications, that they don't treat their customers well. But if I take too little reservations, I'm going to have an empty flight that I still have to send out because there's people expected to go on the flight, and I'm going to have to pay for the gas, I'm going to pay for the taxes, I'm going to pay for the labor. So what's that delicate balance? And I intentionally chose a probability that would make this harder to do. So what we're going to do, or what I'm asking students to do, is just decide upon a number of reservations. So for this first time, let's say we're going to take 26 reservations, like it or not. Well, when I did 26 different reservations, I found out it took me 24 to actually fill the plane, and then I had 18 and 20 show up, which in those cases were shows, which means I overbooked by 2 because I have to still take those reservations because I took them and they showed up. So in this case, I had a situation where I had 2 overbooked. Then I did this again with 26 reservations, but this time, by the time I got to my 26th reservation, you'll see that I did not even fill up this seat. I had 25, which was a no-show, 27, which was a no-show, so I had 1, 2, 3, 4 seats, which meant this was underbooked. So it's kind of interesting. I took the same number of reservations, but one situation was where I had 2 that were overbooked and 4 that were underbooked. Then I did a couple more simulations with students, and you can see in this case they continued to take 26, and sometimes they got 3 overbooked because they had a 17 and 3 along with the 21 show up. But they also had a 26. Actually, it only took 22 reservations, but the 23rd, the 24th, and let's say the 25th showed, but one of them did not show. So you don't have to count that as an overbooking. If they don't show, that doesn't count. And then another time for a simulation I had just come up 1 short. And then finally, there was another time with 26 reservations. It was perfect, and there was no over and under bookings. And this is something that I would ask students to do. And we would actually put up a chart. And so some students might take 24, some students might take 25, some students might take 26. And it's kind of interesting. Sometimes I can have, let's say, 24 reservations, and a couple students will get it perfect on, and there are other ones that will be way off, both in the underbooking and in the overbooking. Might be even the same person with the same number. There is no perfect number for this. There are numbers for reservations that are better than other ones, but there's no way to prevent a reservation like this. And so that brings us to the end of our probability simulations.